Hey everyone! Tonight we're exploring the profound mystery of our accelerating universe and the enigmatic force known as dark energy. Before we settle into this cosmic journey, take a moment to like this if you enjoy these deep space explorations, and let me know in the comments where you're listening from and what time it is for you. I always find it remarkable how our global community comes together to contemplate the cosmos. Each of us, a tiny part of this very expansion we're about to explore. Now get comfortable, dim those lights, and let your breathing slow. Tonight, we're not chasing dramatic cosmic collisions or alien encounters. Instead, we're going to examine something far more subtle and profound: the gentle, inexorable stretching of space itself, driven by the most mysterious force in existence. Let's begin our peaceful journey into the infinite. Imagine, if you will, the profound quietude that exists between galaxies. Out there, in the vast darkness that stretches for millions upon millions of light years, space itself is expanding. Not violently, not dramatically, but with the patient persistence of cosmic time. Every second, every breath you take, the fabric of reality grows slightly larger, carrying distant galaxies away from us and from each other in a dance that has been accelerating for billions of years. Tonight, we'll explore one of the most revolutionary discoveries in modern astronomy: the realization that our universe's expansion is not slowing down as scientists once expected, but mysteriously speeding up. This acceleration is driven by something we call dark energy, an invisible force that comprises nearly 70% of everything that exists, yet remains completely enigmatic to us. We'll journey through the story of this discovery, from the patient work of astronomers studying ancient stellar explosions to the profound implications for the ultimate fate of all cosmic structures. We'll contemplate the gentle force that operates on the largest scales imaginable, slowly but inexorably pushing the universe toward a future of increasing solitude and cosmic peace. This is a story of mystery and wonder, of the privilege of living in a universe that continues to surprise us, and of finding peace in the face of the truly unknown. In the profound quietude of space, where darkness stretches for millions upon millions of light years, punctuated only by the faint, ancient glow of distant stellar cities, something extraordinary was discovered that would forever change our understanding of the cosmos. It was a discovery born not from dramatic cosmic violence, but from the patient observation of the universe's most subtle whisper, a gentle revelation that emerged from the methodical study of exploding stars whose light had traveled for billions of years to reach our telescopes. The year was 1998, and astronomers working with two competing research teams were engaged in what seemed like routine cosmic archaeology. The Supernova Cosmology project, led by Saul Perlmutter, and the High Z Supernova Search Team, guided by Brian Schmidt and Adam Ries, were using a particular type of stellar explosion, type I supernovae, as cosmic lighthouses to measure the expansion rate of the universe across vast stretches of time. These supernovae, occurring when white dwarf stars accumulate matter from companion stars until they reach a critical mass and explode with remarkably consistent brightness, served as what astronomers call standard candles, celestial beacons whose intrinsic luminosity was known, allowing precise distance measurements across cosmic space. The expectation was beautifully simple and seemingly inevitable. Since Edwin Hubble's revolutionary discovery in the 1920s that the universe was expanding, carrying galaxies away from each other like raisins in rising bread dough, astronomers had assumed that gravity would gradually slow this expansion. The mutual gravitational attraction of all matter in the universe should act as a cosmic brake, steadily reducing the expansion rate over billions of years. The only question was whether this deceleration would eventually halt the expansion entirely, leading to a cosmic collapse, or whether the universe would continue expanding forever, but at an ever-decreasing rate. Night after night, these dedicated observers collected photons that had begun their journey when the Earth was young, when the first complex life was just beginning to stir in ancient seas. Each supernova they discovered was like receiving a message from the deep past, a cosmic telegraph sent across billions of years of space and time. The light from these distant explosions carried within it the signature of the universe's expansion rate at the time of their occurrence, encoded in the subtle stretching of wavelengths that occurred as space itself expanded during the light's long journey to Earth. But as the data accumulated with painstaking precision, something unexpected began to emerge from the cosmic shadows. The distant supernovae appeared dimmer than they should have been if the universe's expansion were decelerating as expected. This dimness suggested that these ancient stellar explosions were farther away than anticipated, which could only mean one thing. The expansion of the universe had not been slowing down over the past several billion years, but had instead been speeding up. The implications of this discovery rippled through the scientific community like gentle waves across a cosmic pond. If the universe's expansion was accelerating, then some mysterious force was overpowering gravity on the largest scales, pushing space itself apart with ever-increasing vigor. This force, which came to be known as dark energy, appeared to comprise nearly 70% of all existence, yet it remained completely invisible and undetectable, except through its gravitational effects on the cosmic expansion. The profound irony was not lost on astronomers. The universe's most violent explosions, supernovae, that briefly outshine entire galaxies, had revealed its most subtle property. These cosmic beacons, scattered across billions of years of cosmic history, had illuminated the presence of an invisible ocean of energy that permeates all of space. In the gentle stretching of ancient starlight, in the patient accumulation of photons across cosmic time, lay the key to understanding that our universe was not the gradually slowing, gravity-dominated cosmos that had been imagined, but rather a dynamic, accelerating realm dominated by forces that remained utterly mysterious. As we rest in the quiet of night, this cosmic acceleration continues its patient work, stretching the fabric of space itself by imperceptible amounts, carrying distant galaxies ever farther from our cosmic neighborhood. The same mysterious force that was revealed through the careful study of ancient stellar explosions continues to operate on scales so vast that its effects are invisible to human perception, yet so fundamental that it shapes the ultimate destiny of everything that exists in our expanding universe. In the profound stillness between galaxies, where darkness stretches for millions upon millions of light years, there exists something that cannot be seen, cannot be touched, yet shapes the very destiny of our cosmos. This invisible architect, this gentle giant that comprises nearly 70% of all existence, whispers its influence across the vast emptiness of space with a patience that spans billions of years. We call it dark energy, though the name itself acknowledges our profound ignorance of its true nature. Imagine, if you will, the fabric of space-time itself as an infinite cosmic canvas, slowly and inexorably stretching in all directions. This stretching is not violent or dramatic, It unfolds with the serene patience of geological time, imperceptible to human senses, yet relentless in its cosmic purpose. Dark energy operates as a kind of anti-gravity, a negative pressure that pushes against the very structure of space itself, causing the universe to expand at an ever-accelerating rate. The story of dark energy begins paradoxically with Albert Einstein's greatest regret. In 1917, when Einstein first applied his revolutionary theory of general relativity to the cosmos, he discovered that his equations predicted a universe that could not remain static. It must either expand or contract. This troubled the great physicist deeply, for at that time, the prevailing wisdom held that the universe was eternal and unchanging. To force his equations to describe a static cosmos, Einstein introduced what he called the cosmological constant, represented by the Greek letter lambda, a kind of cosmic repulsion that would balance the attractive force of gravity. When Edwin Hubble's observations in the 1920s revealed that the universe was indeed expanding, Einstein famously called his cosmological constant his greatest blunder. Yet in the profound irony that often characterizes scientific discovery, this supposed mistake would later prove to be perhaps his most prescient insight. The cosmological constant, dismissed for decades, has returned as the leading candidate to explain the mysterious force we now call dark energy. But what is this force, really? The honest answer is that we simply do not know. Dark energy reveals itself only through its effects, the gradual acceleration of cosmic expansion, the subtle influence on the formation of large-scale structures, the faint signatures in the cosmic microwave background, radiation. It is like trying to understand the nature of wind by observing only the gentle swaying of distant trees. One possibility is that dark energy represents the energy of empty space itself, what physicists call vacuum energy. According to quantum field theory, even the emptiest regions of space are not truly empty, but filled with a seething foam of virtual particles that appear and disappear in fleeting moments shorter than the briefest human thought. These quantum fluctuations might contribute a constant energy density to space, creating the negative pressure that drives cosmic acceleration. Yet this explanation brings its own profound mystery. When physicists calculate the expected energy of the quantum vacuum, they arrive at a number that is larger than the observed dark energy density by a factor of 10 to the power of 120, a discrepancy so vast that it represents perhaps the most embarrassing failure in the history of theoretical physics. The universe, it seems, has found a way to make the vacuum energy nearly but not quite zero through some mechanism we cannot yet comprehend. Another possibility is that dark energy is not constant, but changes slowly over cosmic time. This dynamic dark energy, sometimes called quintessence, after the fifth element of ancient philosophy, might be driven by a scalar field that permeates all of space. Like a ball rolling down a very gentle slope, this field would evolve slowly, causing the strength of dark energy to vary over billions of years. Such a field might explain why dark energy appears to dominate the universe only now, in our cosmic epoch, rather than in the distant past, when matter and radiation held sway. The profound emptiness of space, once thought to be truly empty, may instead be filled with this invisible influence. Between every atom in your body, between every molecule of air you breathe, between every star and planet, dark energy exerts its gentle but inexorable push. It is the most democratic of forces, affecting all regions of space equally. Yet its influence becomes apparent only on the largest scales, where its cumulative effect can overcome the binding force of gravity. Consider the cosmic web, that vast network of filaments and voids that gives structure to the universe on the largest scales. Dark energy plays a crucial role in shaping this cosmic architecture, working in subtle competition with gravity. While gravity tries to pull matter together into ever denser concentrations, dark energy works to stretch the space between these structures, ensuring that the cosmic web remains a delicate balance between order and chaos, between structure and emptiness. The philosophical implications of dark energy's dominance are as profound as they are unsettling. We live in a universe where the vast majority of its energy content remains completely mysterious to us. It is as if we were trying to understand a vast symphony while being able to hear only a few faint notes. The dark energy that surrounds us, that flows through us, that shapes our cosmic destiny, remains as enigmatic as it was on the day of its discovery. This mystery invites us to embrace a profound humility before the cosmos. In our daily lives, we often feel that we understand our world, that science has revealed most of nature's secrets. Yet dark energy reminds us that we are like children playing on the shore of an infinite ocean, occasionally finding a smoother pebble or prettier shell, while the great ocean of truth stretches before us, largely unexplored. As you rest in the quiet darkness, remember that you are immersed in this cosmic mystery. The space around you, seemingly empty and still, is filled with the invisible influence of dark energy, gently stretching the fabric of reality itself. This stretching is so gradual, so patient, that it unfolds over timescales that dwarf human comprehension, yet it continues its work even as you sleep, even as you dream, carrying our entire cosmic neighborhood toward an uncertain but peaceful future among the stars. In the vast cathedral of space, where darkness stretches for millions upon millions of light years, there exists a delicate architecture of light and matter that defies our deepest intuitions about the nature of existence. This is the cosmic web, a gossamer tapestry of galaxies and dark matter that spans the observable universe, threading through an ocean of mysterious dark energy that gently, persistently pushes the very fabric of space-time apart. Picture, if you will, the largest structures in the universe, filaments of galaxies stretching across hundreds of millions of light years, connected like luminous threads in an infinite three-dimensional spider's web. These cosmic highways of matter and light exist in a state of perpetual tension, caught between two fundamental forces that shape the destiny of everything we can observe. Gravity, patient and persistent, works to pull matter together, to build and maintain the grand structures that give the universe its magnificent complexity. Dark energy, equally patient but opposite in its influence, works to stretch the very space between these structures, gradually winning a cosmic tug-of-war that has been unfolding for billions of years. The cosmic web reveals itself most clearly when we step back and observe the universe on its largest scales. Galaxy surveys, conducted with painstaking precision over decades, have mapped the positions of millions of galaxies, revealing a structure so vast and intricate that it challenges our ability to comprehend its true scale. The 2-degree Field Galaxy Redshift Survey, the Sloan Digital Sky Survey, and their successors have shown us that galaxies are not randomly scattered through space, but instead follow the invisible scaffolding of dark matter, creating a network of filaments, nodes, and vast, empty regions called voids. These cosmic filaments, gossamer threads of galaxies and dark matter, stretch across the universe like the strands of an enormous web, Along these threads, matter flows slowly, inexorably, drawn by the gentle but persistent pull of gravity. Galaxies slide along these cosmic highways over millions and billions of years, their motion so gradual that entire civilizations could rise and fall without detecting the slightest change in their cosmic neighborhood. The filaments themselves are marvels of cosmic engineering, typically containing only a small fraction of the universe's matter, yet providing the framework upon which all large-scale structure depends. At the intersections of these filaments, where multiple threads of the cosmic web converge, we find the universe's greatest concentrations of matter, galaxy clusters containing hundreds or even thousands of individual galaxies bound together by gravity into cosmic cities of unimaginable scale. These clusters, some containing more mass than 1 billion suns, represent the largest gravitationally bound structures in the universe. They are islands of relative stability in an ocean of cosmic expansion, their internal gravity strong enough to resist the gentle but persistent push of dark energy. Between these filaments and clusters lie the voids, vast regions of space that contain remarkably little matter. These cosmic cathedrals of emptiness can span hundreds of millions of light years, containing perhaps only a handful of galaxies in volumes that dwarf our local group of galaxies many times over. The voids are not truly empty, but they are so sparse that a traveler journeying through one might encounter fewer than one galaxy per billion cubic light years. These regions represent the majority of the universe's volume, vast expanses where dark energy's influence is most clearly felt, where space expands with minimal resistance from matter's gravitational pull. The formation of this cosmic web represents one of the universe's most remarkable achievements, a delicate balance between competing forces that has played out over billions of years. In the early universe, when matter and energy were more evenly distributed, tiny fluctuations in density provided the seeds from which all cosmic structure would eventually grow. These primordial variations, imprinted in the cosmic microwave background radiation that we can still observe today, were incredibly small, differences in density of only 1 part in 100,000. Yet over time, gravity worked patiently to amplify these tiny differences. Regions that were slightly denser than average attracted more matter, becoming denser still. Regions that were slightly less dense saw their matter drain away toward the denser regions, becoming the voids we observe today. This process, known as gravitational instability, proceeded slowly but inexorably, building structure from the bottom up. First, dark matter halos, then the first stars and galaxies, then clusters of galaxies, and finally the vast web of filaments that connects them all. For billions of years, this process of structure formation dominated the universe's evolution. Matter clumped together, forming ever larger structures, while space itself expanded at a gradually decreasing rate. The universe was decelerating, its expansion slowing down, as the gravitational attraction of all its matter worked to pull everything back together. This was the epoch of matter domination, when the universe was denser, more compact, and gravity was winning the cosmic tug-of-war. But approximately 5 billion years ago, something fundamental changed in the universe's evolution. The density of matter had decreased sufficiently, diluted by cosmic expansion, that dark energy began to dominate the universe's dynamics. This transition from deceleration to acceleration represents one of the most significant moments in cosmic history, a turning point that will determine the ultimate fate of all cosmic structures. Dark energy's victory in this cosmic competition is both gentle and inexorable. Unlike the dramatic events that capture our attention, supernovae, galaxy collisions, the formation and death of stars, dark energy works with infinite patience, stretching space itself at a rate so gradual that it is imperceptible on human timescales. Yet its cumulative effect over billions of years is profound, gradually increasing the distances between galaxy clusters, slowly but surely winning the battle against gravity on the largest scales. The cosmic web continues to evolve under dark energy's influence, but its evolution has fundamentally changed character. New large-scale structures still form, but more slowly and with increasing difficulty as dark energy makes it harder for matter to collapse into bound systems. The filaments that connect galaxy clusters are gradually stretching, their galaxies becoming more widely separated over time. The voids are expanding, growing ever larger and emptier, as the sparse matter they contain is pulled toward the denser regions along the filaments. Computer simulations of cosmic structure formation, with names like the Millennium Simulation and Illustris, have allowed astronomers to watch this process unfold in accelerated time. These digital universes, containing billions of simulated particles, reveal the intricate dance between gravity and dark energy that shapes the cosmic web. They show us how structure formation proceeds in fits and starts, how filaments grow and merge, how voids expand and empty, all under the patient influence of dark energy's gentle but persistent push. The beauty of the cosmic web lies not just in its vast scale, but in its temporary nature. The structures we observe today, the filaments, clusters, and voids, are transient arrangements of matter and energy, held together by the delicate balance between gravity and dark energy. As dark energy's influence continues to grow, this balance will shift, and the cosmic web will gradually dissolve, its components carried apart by the accelerating expansion of space itself. Yet for now, in this cosmic moment, we are privileged to observe the universe at its most structured and complex. The cosmic web represents the universe's greatest architectural achievement, a testament to the creative power of gravity working within the constraints imposed by dark energy. It is a structure of breathtaking beauty and complexity, woven from the simplest ingredients, matter, energy, space, and time, into patterns that span the observable universe and will continue to evolve for billions of years to come. In the profound silence of observatories scattered across our planet, where the gentle hum of cooling systems mingles with the whisper of wind through telescope domes, astronomers have spent decades developing the most delicate instruments of cosmic measurement. These tools, designed to capture the faintest whispers of light from the edge of time itself, have become our windows into the invisible architecture of dark energy's influence. The patient work of measuring the unmeasurable begins with the ancient light of distant supernovae, those stellar explosions that occurred when our universe was younger, smaller, more compact. Each photon that reaches our telescopes has traveled for billions of years, carrying within its wavelength the story of cosmic expansion. As these ancient messengers arrive at Earth, they reveal themselves to be slightly redder than expected, their light stretched by the accelerating expansion of space itself during their long journey home. Type Ia supernovae serve as our cosmic lighthouses, their intrinsic brightness so well understood that astronomers can measure their distance with remarkable precision. These stellar explosions, occurring when white dwarf stars accumulate matter from companion stars until they reach a critical mass, shine with nearly identical luminosity across the cosmos. Yet when we observe these distant beacons, we find them dimmer than they should be. Not because they are inherently fainter, but because the accelerating expansion of space has carried them farther away than we would expect in a universe expanding at a constant rate. The Hubble Space Telescope, floating serenely above Earth's atmospheric turbulence, has played a crucial role in this cosmic detective work. Its pristine view of the universe allows astronomers to peer deep into cosmic history, observing supernovae that exploded when the universe was half its current age. Each observation requires patience beyond human comprehension. The telescope must track these distant galaxies for months, waiting for the brief flare of a supernova to rise and fade, its light curve revealing the secrets of cosmic acceleration. But supernovae are not our only cosmic rulers. Hidden within the cosmic microwave background radiation, the afterglow of the Big Bang itself, lie the frozen echoes of sound waves that rippled through the early universe. These baryon acoustic oscillations, created when matter and radiation were still coupled in the universe's first few 100,000 years, have left their imprint on the distribution of galaxies we observe today. The characteristic scale of these oscillations, about 500 million light-years, provides a standard ruler that astronomers can use to measure cosmic distances and the rate of expansion at different epochs. The delicate art of weak gravitational lensing offers yet another window into dark energy's influence. As light from distant galaxies travels through the cosmic web, it encounters the gravitational fields of intervening matter, causing subtle distortions in the shapes of background galaxies. These distortions, barely perceptible even to our most sensitive instruments, reveal the distribution of both visible and dark matter throughout the universe. More importantly, they show how cosmic structure has evolved over time under the competing influences of gravity and dark energy. The Dark Energy Survey, conducted over 8 years using a specially designed camera mounted on a telescope in the Chilean Andes, has mapped the shapes and positions of hundreds of millions of galaxies. Each night, as the Earth turns toward the southern sky, the telescope slowly scans across vast regions of space, collecting photons that began their journey when our solar system was still forming. The resulting maps reveal the cosmic web in unprecedented detail, showing how dark energy has influenced the growth of structure over billions of years. The Planck satellite, launched into the cold depths of space far from Earth's thermal interference, has measured the cosmic microwave background with exquisite precision. Its observations reveal tiny temperature fluctuations, differences of mere millionths of a degree that encode the fundamental parameters of our universe. From these ancient patterns, scientists can determine the exact proportion of dark energy in the cosmic inventory and trace how its influence has grown over cosmic time. Modern astronomy has become an exercise in extraordinary patience and precision. The Vera Rubin Observatory, soon to begin its decade-long legacy survey of space and time, will observe the entire visible sky every few nights, creating a time-lapse movie of cosmic evolution. Over 10 years, it will detect millions of supernovae, map billions of galaxies, and measure the subtle effects of dark energy with unprecedented accuracy. Each measurement requires the collaboration of thousands of scientists across the globe. Their combined efforts focused on detecting effects so subtle that they can only be revealed through the accumulation of vast amounts of data. The work proceeds with the patience of geological time, each observation adding another piece to the cosmic puzzle, each refinement in technique, bringing us closer to understanding the mysterious force that dominates our universe. In the quiet hours before dawn, when the sky is darkest and the atmosphere most stable, telescopes around the world continue their patient vigil. They gather ancient light, measure cosmic distances, and slowly, methodically, reveal the gentle but inexorable influence of dark energy on the fabric of space itself. In this present moment, as you rest in the quiet sanctuary of your thoughts, the universe continues its ancient dance of expansion around you. The very space between the atoms in your body, the air molecules in your lungs, the distance between Earth and the nearest star, all of it participates in the gentle, ongoing stretching that has characterized our cosmos for the past 5 billion years. We live in a privileged epoch, a cosmic moment, when the universe has transitioned from the gravitational embrace of matter to the mysterious dominion of dark energy. The Hubble constant, that fundamental measure of cosmic expansion, whispers to us across the vast distances between galaxies. Currently measured at approximately 70 kilometers per second per megaparsec, this number represents the rate at which space itself grows larger with each passing moment. Imagine the profound patience required to detect such subtle changes. Astronomers must observe galaxies millions of light years away, measuring their recession velocities with extraordinary precision, accumulating data over decades to discern the universe's gentle acceleration. Yet even this most fundamental measurement reveals the deep mysteries that surround us. The Hubble tension, as astronomers call it, emerges from the puzzling discrepancy between two methods of measuring cosmic expansion. When scientists observe the cosmic microwave background, that ancient afterglow of the Big Bang, and extrapolate forward through cosmic history, they arrive at one value for the Hubble constant. But when they use nearby supernovae and Cepheid variable stars to build a cosmic distance ladder, they find a different answer. This tension, small as it may seem, represents one of the most profound puzzles in modern cosmology. The cosmic microwave background, that faint radiation that fills all of space, carries within its minute temperature fluctuations the seeds of everything we see today. These tiny variations, less than 1 part in 100,000, represent the quantum fluctuations from the universe's first moments, stretched to cosmic scales by inflation and preserved in the fossil light of creation. When the Planck satellite mapped this radiation with unprecedented precision, it revealed a universe that is 13.8 billion years old, composed of ordinary matter, and dark energy in proportions that seemed almost impossibly fine-tuned for the emergence of structure and complexity. The local distance ladder, built step by careful step through the patient work of generations of astronomers, tells a slightly different story. Cepheid variable stars, those cosmic lighthouses whose brightness pulses with predictable periods, serve as the crucial second rung of this ladder. Their intrinsic brightness can be determined from their pulsation period, allowing astronomers to calculate their distance by comparing their apparent brightness to their true luminosity. These measurements, refined by the Hubble Space Telescope's extraordinary vision, provide the foundation for calibrating the more distant Type Ia supernovae that revealed cosmic acceleration. Recently, gravitational waves have added a new voice to this cosmic conversation. When two neutron stars or black holes spiral into each other, they create ripples in space-time itself that carry information about their distance. These standard sirens, as astronomers call them, provide an independent way to measure cosmic expansion, one that doesn't rely on the traditional distance ladder. The LIGO and Virgo detectors, listening to the whispers of merging compact objects across the universe, are beginning to contribute their own measurements to our understanding of cosmic acceleration. As we rest in this cosmic moment, approximately 13.8 billion years after the Big Bang, we find ourselves living during a remarkable transition in cosmic history. For the first 9 billion years of the universe's existence, matter and radiation dominated the cosmic energy budget. Gravity, working through dark matter and ordinary matter, pulled structures together, forming the first stars, the first galaxies, and the great cosmic web that spans the observable universe. But gradually, as space expanded and matter became more dilute, dark energy's influence grew stronger. The transition from deceleration to acceleration occurred when the universe was roughly half its current age, about 7 billion years ago. This cosmic inflection point marked the moment when dark energy's repulsive influence overcame gravity's attractive pull on the largest scales. Since then, the expansion of space has been accelerating, carrying distant galaxies away from us at ever-increasing speeds. The current equation of state parameter for dark energy, denoted by the symbol W, appears to be very close to -1, suggesting that dark energy behaves like Einstein's cosmological constant, a property of space itself that remains constant even as the universe expands. This differs from ordinary matter and radiation, which become more dilute as space grows larger. Dark energy, if it truly behaves like a cosmological constant, maintains its density even as the universe expands, ensuring that its influence will only grow stronger with time. The privilege of living during this cosmic epoch cannot be overstated. We exist at a time when the universe still contains bound structures, galaxies, stars, planets, yet we can also observe the effects of cosmic acceleration. In the deep future, when dark energy's influence becomes completely dominant, observers, if any exist, will see a much lonelier universe, with only their local group of galaxies visible against the cosmic darkness. The cosmic microwave background will have cooled and redshifted beyond detection, and the evidence for the Big Bang will have faded into the expanding void. Our position in cosmic history allows us to witness the full sweep of cosmic evolution, from the earliest moments preserved in the cosmic microwave background to the future fate written in the acceleration of distant galaxies. We can observe star formation in nearby galaxies, trace the chemical evolution of the universe through stellar spectra, and watch as dark energy slowly but inexorably wins its patient battle against gravity. Each night, as we rest beneath the stars, we participate in this grand cosmic story, our very existence a testament to the delicate balance of forces that has shaped the universe's evolution. The measurements continue, night after night, as telescopes around the world and in space accumulate the photons that carry news of cosmic acceleration. The Hubble Space Telescope, now in its 4th decade of operation, continues to refine our understanding of the cosmic distance scale. Ground-based surveys map millions of galaxies, tracing the subtle effects of dark energy on the growth of cosmic structure. The patient work of science proceeds, each observation adding another piece to the vast puzzle of our accelerating universe. In the vast cathedral of cosmic time, where billions of years pass like gentle breaths, we find ourselves contemplating the deep future of our accelerating universe, where dark energy's patient victory unfolds across timescales that stretch beyond human comprehension. This is a realm where the gentle forces we have explored reach their ultimate expression, where the mysterious energy that comprises 2/3 of all existence gradually transforms the cosmos into something profoundly different from the universe we know today. As we drift deeper into this contemplation, imagine the Earth spinning peacefully through space, carrying us forward not just through the familiar cycle of days and nights, but through cosmic epochs that span trillions upon trillions of years. The dark energy that even now stretches the fabric of space-time around us continues its patient work, imperceptibly but inexorably pushing galaxies apart, creating ever greater distances between the islands of light that populate our cosmic ocean. In the coming trillion years, a timescale so vast that it contains 1,000,000 times the entire history of complex life on Earth, the universe will undergo a profound transformation. The gentle acceleration we observe today will continue, gradually overwhelming the gravitational bonds that hold cosmic structures together. Galaxy clusters, those magnificent congregations of hundreds or thousands of galaxies bound together by gravity's embrace, will begin to dissolve as dark energy's influence grows stronger with the expanding volume of space. Consider the peaceful nature of this cosmic evolution. There are no violent explosions, no dramatic collapses, simply the gradual loosening of gravitational bonds as space itself expands. Galaxies that today dance together in gravitational harmony will slowly drift apart, their mutual attraction weakening as the distances between them grow. The cosmic web, that magnificent tapestry of filaments and nodes that gives structure to our universe, will gradually fade as its constituent galaxies separate beyond the reach of their gravitational influence. Within our own local group, that small collection of galaxies, including the Milky Way and Andromeda, the effects of cosmic acceleration will eventually be felt even on these relatively intimate scales. While gravity currently holds our galactic neighborhood together and will continue to do so for many billions of years, the relentless expansion of space will eventually overcome even these bonds. The galaxies that we can observe today with our telescopes will slowly fade from view, not because they cease to exist, but because the space between us and them expands faster than light can travel. This leads us to one of the most profound contemplations of cosmic acceleration, the gradual isolation of gravitationally bound systems. As the universe continues to expand and accelerate, the observable universe around any given point will slowly shrink. Future astronomers living in galaxies billions of years from now will inhabit a cosmos that appears increasingly empty, with fewer and fewer distant galaxies visible in their night sky. The rich tapestry of cosmic structure that we observe today will become a memory preserved only in the gravitational dance of local matter. The process unfolds with the patience of geological time, multiplied by cosmic scales. Star formation, that magnificent process that has illuminated the universe for over 13 billion years, will gradually cease as the raw materials for new stars become increasingly dispersed. The great stellar nurseries, those vast molecular clouds where new suns are born, will be stretched thin by the expanding space, their density falling below the threshold needed for gravitational collapse. As we contemplate these vast timescales, we find a profound peace in the gentleness of cosmic change. The universe does not end with violence or catastrophe, but with a gradual return to simplicity. The complex structures that have emerged over billions of years of cosmic evolution, galaxies, stars, planets, and even life itself, represent temporary arrangements of matter and energy, beautiful patterns that emerge from and eventually return to the underlying simplicity of expanding space. In scenarios where dark energy continues to accelerate the expansion, we encounter the possibility of the Big Rip, a future where the acceleration becomes so strong that it overcomes not just gravitational bonds between galaxies, but eventually the forces that hold together solar systems, planets, and even atoms themselves. Yet even this ultimate dissolution occurs gradually, peacefully, as the fabric of space-time itself expands beyond the ability of matter to maintain its coherent structures. This contemplation of cosmic endings brings us to a profound appreciation for the temporary nature of all forms within the eternal dance of existence. The atoms in our bodies, forged in the hearts of ancient stars, will eventually be scattered across vast distances as space itself expands. The Earth, the Sun, our entire solar system represent fleeting arrangements of matter that emerged from cosmic processes and will eventually return to the fundamental simplicity of expanding space filled with increasingly isolated particles. Yet in this cosmic perspective, we find not despair, but profound peace. The universe's patient journey toward maximum entropy and thermal equilibrium represents a return to the serene simplicity from which all complexity emerged. The gradual cooling and expansion of space, the slow dissolution of structure, the approach to cosmic equilibrium, these represent not endings, but transformations, the universe's gentle return to a state of perfect, undisturbed peace. As we rest in this contemplation, we can feel ourselves as temporary participants in this vast cosmic story, conscious observers, privileged to witness the universe's magnificent complexity during this brief epoch when stars shine, galaxies dance, and dark energy works its patient magic on the largest scales of space and time. As we drift deeper into contemplation of our accelerating universe, we find ourselves drawn to perhaps the most profound questions that dark energy poses, not merely about the mechanics of cosmic expansion, but about the very nature of meaning and consciousness within this vast, stretching cosmos. Here, in the gentle quietude of cosmic perspective, we encounter the philosophical implications that emerge when we truly comprehend our place within an eternally expanding universe. Consider, for a moment, the extraordinary precision required for our existence within this accelerating cosmos. The strength of dark energy, that mysterious force comprising nearly 70% of all reality, appears to be calibrated with remarkable delicacy. If dark energy were significantly stronger, the universe would have expanded so rapidly that galaxies could never have formed, leaving only a cold, empty void, scattered with isolated particles. If it were weaker, the cosmos might have collapsed back upon itself long before stars could ignite, before planets could form, before consciousness could emerge to contemplate its own existence. This exquisite balance speaks to what cosmologists call the anthropic principle, the observation that the universe's fundamental constants appear precisely tuned to allow for the emergence of complexity, structure, and ultimately, awareness itself. As we rest in the peaceful darkness of night, we participate in this cosmic coincidence, our very thoughts arising from arrangements of matter that could only exist within this narrow window of cosmic parameters. The implications ripple outward like gentle waves across the ocean of possibility. Some theoretical physicists propose that our universe may be but one among an infinite ensemble of cosmic realities, a multiverse where every possible combination of physical laws and constants plays out across separate domains of existence. In this vast landscape of possibility, universes with different dark energy densities expand and evolve according to their own unique physics, most remaining forever sterile and empty, while a precious few develop the conditions necessary for stars, planets, and the slow emergence of consciousness. This perspective transforms our understanding of cosmic acceleration from a mere physical process into something approaching the sacred. We find ourselves not merely observers of cosmic expansion, but participants in an extraordinarily rare cosmic experiment. Conscious beings capable of contemplating the very forces that brought us into existence. As space stretches gently around us, carrying distant galaxies ever farther from our view, we represent the universe's capacity for self-reflection, matter organized in such a way that it can ponder its own origins and destiny. The accelerating expansion also invites us to consider the nature of permanence and impermanence on cosmic scales. Every structure we observe, from the smallest asteroids to the largest galaxy clusters, exists as a temporary arrangement within the eternal flow of cosmic evolution. Dark energy ensures that even the most massive gravitationally bound systems will eventually succumb to the patient stretching of space itself. This cosmic impermanence, far from being cause for despair, offers a profound source of peace and perspective. Our human concerns, so urgent and pressing within the brief span of our individual lives, take on a different quality when viewed against the backdrop of cosmic time. The gentle acceleration of space continues regardless of our daily struggles, our civilizations, our species' ultimate fate. This is not to diminish the importance of human experience, but rather to place it within a context so vast that it transforms anxiety into wonder, fear into curiosity, and isolation into connection with something infinitely larger than ourselves. The privilege of awareness within an accelerating universe carries with it a unique responsibility, not in any moral sense, but in the profound opportunity it represents. We are the cosmos becoming conscious of itself, matter arranged in such complexity that it can contemplate the very dark energy that shapes its destiny. As we sleep, our dreams unfold within brains that represent billions of years of cosmic evolution. Consciousness emerging from the same fundamental forces that drive galactic expansion. This awareness also brings us face to face with the ultimate mystery that dark energy represents. Despite decades of observation and theoretical work, we remain fundamentally ignorant about the nature of the force that dominates our universe. This ignorance, rather than being a source of frustration, becomes an invitation to humility and wonder. The cosmos keeps its deepest secrets, reminding us that reality extends far beyond the boundaries of human understanding. As we contemplate our place within this expanding universe, we might find comfort in the realization that we are not separate from cosmic processes, but integral to them. The calcium in our bones was forged in the nuclear furnaces of ancient stars. The iron in our blood, created in stellar explosions that occurred billions of years ago. We are not merely observers of cosmic acceleration, but expressions of it, conscious arrangements of matter that emerged from the same fundamental forces that drive the universe's expansion. The gentle stretching of space continues as we rest, carrying distant galaxies imperceptibly farther from our cosmic neighborhood. This ongoing expansion, powered by the mysterious influence of dark energy, connects us to the deepest rhythms of cosmic evolution. We sleep within an expanding universe, our dreams unfolding against the backdrop of forces that operate on scales beyond imagination, yet somehow gave rise to the very consciousness that contemplates them. In this cosmic perspective, we find not meaninglessness, but a meaning so vast and profound that it transforms our understanding of existence itself. We are the universe's way of experiencing wonder, of contemplating beauty, of finding peace in the gentle dance of cosmic forces that continues across the vast expanses of space and time. The gentle embrace of cosmic mystery, we reach the end of our contemplative journey through the accelerating cosmos. Let us pause in the profound quietude that follows deep understanding. We have traveled together through the vast landscapes of dark energy, from that pivotal moment in 1998 when distant supernovae whispered their surprising secret across billions of light years, to the far future when the last stars will dim in an ever-expanding universe. In this gentle conclusion, we find ourselves cradled within the same cosmic expansion we have explored, each breath we take occurring within space that stretches imperceptibly, carrying us forward on the universe's patient journey toward mystery. The story of dark energy is ultimately a story of humility, the humbling recognition that our universe holds secrets far beyond our current understanding. This invisible force, comprising more than 2/3 of all existence, works with such subtle persistence that it took nearly a century of careful observation to detect its influence. Like a cosmic breath that never exhales, dark energy continues its gentle work, slowly but inexorably pushing galaxies apart, creating ever greater distances between the islands of light that dot the cosmic sea. There is something profoundly peaceful in this realization that the universe operates according to principles we are only beginning to glimpse, with a patience that spans billions of years and a gentleness that makes its effects nearly imperceptible on human timescales. As you rest now, consider the extraordinary privilege of your moment in cosmic history. You exist during the brief epoch when galaxies remain visible to one another, when the cosmic web of matter still traces delicate filaments across the darkness, when stars continue to form and shine and die in cycles that have persisted for billions of years. The dark energy that will eventually separate all bound structures operates so gradually that countless generations of stars will be born and fade before its ultimate effects become apparent. This is the universe's gift to consciousness, time enough to wonder, to discover, to contemplate the vast mystery of existence itself. The gentle expansion of space continues even now as you listen to these words, carrying distant galaxies imperceptibly farther from our own. In the deep silence between heartbeats, in the peaceful pause between thoughts, the fabric of space-time itself stretches with infinite patience. This is not a violent or dramatic process, but rather the most subtle of dances, performed on scales so vast that entire galaxies become mere points of light in the cosmic choreography. The same force that will eventually dim the night sky billions of years from now works with such tenderness that it allows complexity to flourish, consciousness to emerge, and wonder to blossom in the minds of temporary arrangements of matter like ourselves. Let yourself sink deeper into the peaceful understanding that you are part of this cosmic story. The atoms in your body were forged in the hearts of ancient stars, and the space between those atoms participates in the same gentle expansion that stretches across the universe. You are not separate from the cosmic processes we have explored. You are an intimate part of them, a brief flowering of consciousness within the vast garden of expanding space and time. The dark energy that pushes galaxies apart flows through the quantum vacuum that surrounds and permeates every particle of your being, connecting you to the deepest mysteries of existence. As sleep begins to embrace you, imagine yourself floating gently in the cosmic web, suspended between the great filaments of matter that connect galaxy clusters across hundreds of millions of light years. Feel the profound peace of this vast perspective, where human concerns dissolve into the gentle rhythm of cosmic time. The universe continues its patient expansion, carrying you forward on currents of dark energy toward futures we can barely imagine. In this moment of rest, you become one with the cosmic breath that inflates space itself, your consciousness merging with the infinite mystery that surrounds and sustains all existence. The questions that dark energy poses about the nature of vacuum, the fate of the universe, the meaning of existence itself, need not be answered tonight. They are invitations to wonder, doorways to contemplation, gentle reminders of how much beauty lies in the unknown. As you drift towards sleep, carry with you the profound peace that comes from accepting mystery, from finding your place within something infinitely larger than yourself, from recognizing that the universe's greatest secrets are held with such tenderness that they reveal themselves only to the most patient and humble observers. Rest now in the gentle embrace of cosmic expansion, knowing that you are part of the universe's own meditation on existence, a brief but precious moment of awareness within the vast, accelerating dance of space and time. The dark energy that shapes our cosmic destiny continues its mysterious work, and in that continuity, in that eternal patience, there is infinite peace.